Today we're solving quadratic equations with another method. This is using the quadratic formula. In the past, we've drawn the parabola and we can see that the solutions for x are at, in this case, -3 and +3. It's easy to see where the solutions are because they're going through a whole number. I can also use the equation x squared minus 9, and I can factor that equation. This is basically the same as the parabola we have drawn, and if I look at that, the solutions are x equal 3 and x equal -3. This method was used was factoring. In this case, I could have also added the 9 on the other side. I've done the exact same thing, found the solution, but I used the square root method. Now here's the thing. Not all equations are going to work this way. I can't factor everything, and I can't use the square root method on everything. Sometimes I'm going to have to use another method. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Now, to find the a, b, and c, I'm going to use the standard form of the equation, ax squared plus bx plus c, where the a is the coefficient a, b, and then c. Okay, when you're plugging in the numbers, don't plug in the x's. That's why I'm crossing them out. You just plug in the number a, b, and c into the quadratic formula. All right, let's go ahead and try this. This example, we're going to write out the quadratic formula again so I have it to look at. Okay, my example is going to be x squared plus 8x plus 19. Always make sure that your equation equals 0. Sometimes we'll try to trick you and put something on the other side. You need to move everything to one side. In this case, a equals 1, b equals 8, and c is going to equal 19. So I'm going to start plugging my numbers in to the formula. I have -8 plus or minus the square root of 8 squared minus 4 times 1 times 19. I'm going to put all this over, dividing it by 2 times 1. The very first thing I'm going to do is the part underneath the square root, because the square root's kind of like parentheses. We have to follow PEMDAS. Okay, notice I only multiplied the 2 times 1, so the 2's on the bottom. Okay, so the part underneath the square root is 64 minus 76, which I'm going to go ahead and write that out there. It's -12. So now I have to deal with the -12. The first thing I see is the negative, so I'm going to go ahead and take out the I because I know it's imaginary. Okay, dealing with one piece at a time. X equal -8 plus or minus. I have the I now. The 12 breaks down to 4 and 3. If it didn't break down, I'd leave it. But since it does, I have to go ahead and do as much as I can, simplifying as much as I can. So now the 4 is going to become a 2, and I have an I, and the square root of 3 does not break down anymore, and I'm going to have everything over 2. Now notice that I have a 2, an 8, and a 2. If they are all in these positions, I can go ahead and reduce, because I could actually make these two different fractions. If the 2 was under here with the square root, I can't, because remember, we cannot divide or multiply a whole number with a number inside of a square root. So let's go ahead and reduce. I'm going to divide the 2 and divide 2 into 8, and I'm going to get -4 plus or minus I square root of 3. That is my answer for this problem. Okay, now what if you encounter some different types of calculations? Let's say, for example, you ended up with negative 4 plus or minus 5 divided by 3. I would have to go ahead and calculate that. Since they're all whole numbers, go ahead and calculate that twice. First, I'm going to do the plus, which ends up being negative 4 plus 5 divided by 3. And then I'm going to do the minus, which is negative 4 minus 5 divided by 3, which notice that that ended up being a negative 9. So for the first one, I got 1/3, and for the second one, I get negative 3. In this case, I do end up with two real solutions. Okay. All right, let's do another example. What if, when I'm doing the quadratic formula, I end up with 12 plus or minus the square root of 0 divided by 4? The square root of 0 is really just 0, because 0 times 0 is 0. So if I end up with that, it's really just 12 divided by 4. Because think about that. 12 plus 0, 12 minus 0 is just 12. Okay? Which gives me a 3. Now, here's the thing. I could have two solutions. I could end up with one solution because sometimes you can have one real solution if the vertex is the only thing that's crossing the x-axis. Please remember that sometimes you'll have an I, and sometimes you'll have a square root that does not break down. Okay? All right, that's it for this video. Let's do some more with quadratic equations.